Hello everyone, my name is Jordan Glass and this is Lab 4 Circuits. So, in introduction, the purpose of this lab was to determine how different implementations of batteries, wires, bulbs, and capacitors affect various ohmic properties. We began with a circuit loop that contained two batteries, two resistors in series, and two ammeters. We recorded the current running through the two ammeters and then recorded the voltage difference across different elements of the circuit. We then constructed an RC circuit in which we observed the rate of charging/discharging of a capacitor. With this information, we were able to calculate the RC value using a natural log plot and got a result of negative 0.166 ohms times Faraday, which is seconds. Um, the models we used in this lab were Ohm's law, resistors in series, um, ammeters/voltmeters, charging capacitors over time, and also the discharging. A natural log plot of the change in voltage over the change in initial voltage, and then RC, which is a time constant, time for the voltage across a capacitor to reach 1 over E of its original value. So some sources of error. There are likely no sources of error in our experiment as it wasn't conducted with real materials. It was just an online simulation. Some initial conditions is that we assumed that the wire had negligible resistance and the equipment was fresh. There was no wear and tear on the equipment since it was just online. And the system in this experiment was just a circuit whose components consisted of wires, bulbs, batteries, and capacitors. So prediction, my prediction for the value of I1 was a very large number, while my prediction for I2 was 0.02 amps. This was partially correct, however, I neglected the fact that the current in the wire before the resistors will be the same after due to the fact that the resistors are in series, and both currents actually are supposed to read 0.02 amps, and reversing direction of the inverters had no effect. So when the top emitter is removed and the circuit is no longer connected, the voltage across the 2 points is negative 3 volts, since the part of the circuit on the right will have no current flowing through it, it'll have no voltage. So the voltage over here is 0, and the voltage over here 3 due to the batteries. 0 minus 3 gets a result of negative 3 volts. And there will also be no current since, the current will be 0 since it's not connected. So next we calculated the voltage difference across different parts of the circuit. So VAB equals 3 volts, VCD equals negative 9.6 volts, VEF equals negative 2.04 volts, and VGH equals 0 volts. The current is still 0.02 volts because no resistance is being added. The sum of the voltages should be 0, and mine do add up to 0. When removing the voltmeter and placing it with the ammeter, it reads the same as the other one as no resistance being added again. Resistance of the 47 resistor is 47 ohms, 100 resistor is 100 ohms, wire 0 ohms, and ammeter 0 ohms. And also here is my graph depicting the different components at the bottom and the respective voltage across each component. So for the RC circuit, the light produced by the 10 ohm bulb dissipates over time, and when the capacitor is connected directly to the bulb, it discharges at a similar rate, or it dissipates at a similar rate. And the current gradually decreases as the capacitor gets charged, and when the battery is disconnected, the charge built up on the capacitor starts flowing through the circuit again. So there is a current. It takes 14 seconds for the capacitor to charge as discharge with the 10 ohm bulb and 24 seconds with the 20 ohm bulb. So here's my graph on Excel of the natural log of the change in voltage or the change in initial voltage. And when you graph this, it should be a linear plot, which yields a slope of negative 0.1667, which ends up being the value of negative 1 over RC. So our experimental value does match our computational value. So discussion, what if you were doing this lab in real life, use an actual ammeter? Basically an actual ammeter has a little bit of resistance, so our current calculated would have likely been a little bit lower. And what we're doing this lab in real life and use a real battery to charge a real capacitor with no resistance in the circuit, the capacitor would likely reach charge a little bit slower as the capacitor would add a little bit of resistance, and our battery would not be fresh slash ideal slash never been used like it is in the simulation. Also, in real life, the wire would contribute a little bit of resistance as well, meaning the electrons could not move quite as fast through the wire and thus discharging would be a little bit slower. So overall, we observed that the voltage through a circuit changes depending on where it is in the circuit. However, the current through a circuit when the resistors are in series is the same throughout the circuit. Also, in an RC circuit with a 1 9-volt battery, 30 ohm resistor, and a zero point 0.2 Faraday capacitor, the value of -1 over RC is -0.167. Thank you, that is all.